All right, last live stream of the semester. I didn't receive any questions in advance, no emails, so I'm here in the chat. Big reminders, your homework and your discussion boards are due today. Now, you can always go back and redo an old discussion board for points. That said, um, today is the last day, and I'm probably only going to grade them once today. So, as of tomorrow, you are starting your final exam. That is the only thing that is left for you in terms of grading this course. Now, to circumvent any questions, people want to know, what do I need on the final exam? There's actually a very simple formula for this. So tomorrow, probably I'd say about noon, I should be done entering all the grades. Let's say your grade here is G. If you want an any course to figure out what you need on the exam, it's 90 minus your grade times 0.78 divided by 0.22. If you want a B in the course, that 90 now goes down to an 80. If you want a C, a 70. I guess if you want a D, a 60. But that's what you need in order to get what you need to get on the final exam. Now, you cannot do better than 100% on the final exam. So if you were like, well, I want an A, and you do the 90, it says you need 108 points on the final exam, probably not going to happen. But that said, the earlier you take your exam, the earlier you can argue if you want to contend parts of your grade. That said, grades are due next Wednesday. Technically, they're due next Thursday at noon for us, but that said, they do start harping on us about Wednesday afternoon just because the servers do tend to get saturated with people submitting grades. So, once you take your final exam, if you look at your grade and you go, I wonder if there's a way to bump it up. If you're like 3 points beneath the next grade, definitely not bumping it up for you. If you're within a point, you might have grounds to contend, but that said, if you haven't done all the assignments this semester, that's going to be the first thing I point out. So you need to attempt everything, every discussion board, every homework, every exam, every lab, everything that came in this semester. Then you'll kind of have grounds to request to see if maybe we can regrade something to get you a couple more points back. But that said, we are at the end of the semester, so please don't wait on the final exam. Keep in mind that usually with your exams, your cutoff is at midnight. That is not true with your final exam. As of 5 o'clock Wednesday, the semester is officially over. I cannot accept any grades beyond 5 o'clock unless you declare it incomplete, which there's a lot of paperwork to make that happen, and probably not going to happen unless you have a really extenuating circumstance. So go ahead, get your exams out of the way, and email me if you have any questions in terms of exam, anything looks like it's completely out of left field. For the rest of the exam period, I'm available informally to meet. I would prefer to do emails. I am having to start setting up for the next semester, so a lot of this is setting up Blackboard shells, setting up announcements, setting up syllabi, planning the schedules for the spring. So if you're curious what I'm doing, that's what I'm working on. So again, if you have any questions, shoot me an email. I'm going to prefer to do it by email. If you want to chat in person on Teams, that's possible. But I'm going to really say if it can be done by email, we need to be doing it by email. All right. I did seriously debate just pre-recording a video of like eclipse from the whole semester just to be really obnoxious, but I did not get that motivated. So instead, I'm just pretty much going to screw around on the banjo. If you got any questions, just post them in the chat. Could you recap something about NMR? Yeah, sure. What questions do you have? So chemical shifts are more like guidelines. We use them to approximate what we think the functional group is. But that said, there are a lot of little weird exceptions to situations, particularly when we talk about aromatic compounds in organic too. You would think something being um, super electron rich, like an aromatic compound, you'd expect the electrons to be really shielded. Actually, it's the complete opposite. Things in double bonds tend to be very de-shielded because of how the electrons move in the magnetic field. So, in terms of just looking at a chemical shift in isolation, meaning you have no references, it's kind of what you would use as like a first guess approximation, realizing that it's an approximation. But you can definitely say that something's more or less de-shielded. So if we add oxygen or halogen or nitrogen, we expect the protons to move further to higher chemical shifts, but that exact number is hand wavy at best. Now, if we had a database, it's super precise. So I know there are databases that exist. I don't know how to get access to them. But if you had an NMR spectrum of a molecule, you could actually compare it against a database, and it would be pretty exact. The big thing you would have to do is make sure you're using what's called the same reference compound. And we don't talk about this in organic because it's more of a technical aspect of NMR, but there are different standards. Just because we say something has a chemical shift of 1.8 ppm, well, that's 1.8 ppm relative to a reference compound because the NMR itself is just a big gigantic magnet that you have to calibrate, and you calibrate against a known molecule. So the relative chemical shifts, like whether two peaks vary by 2 ppm or 2.9 ppm, that's an absolute number. But the actual chemical shift itself is going to depend on the reference, and that can shift as much as 1 or 2 ppm. So by itself, without any outside information, I would say a chemical shift is kind of a first guess as to what you have. And you can make qualitative statements about how chemical shifts change with regard to changing what's around a given atom. But the absolute number is kind of hand wavy, and it's really hard to figure out without actually going and conducting an experiment. But the actual like chemical shift, relative chemical shifts of the different peaks, the splitting patterns, all that, if you had a database, you could definitively say with 100% certainty you have a given compound. Because generally speaking, that NMR chemical shift is unique to that given molecule. The splitting patterns, the relative chemical shifts, all of that you can only get with that particular bonding environment. Most of the techniques we talk about, so the IR, the NMR, the mass spec, they're not useful on their own. They're much more useful with a database. This is something that really grates me about how we teach it, and I've heard, for being honest, mostly older instructors talk about you need to be able to identify it with just the spectrum alone, and that's kind of misleading because the whole reason we have databases is to get around that problem. You're also kind of cheating with this course. You're isolating these things by themselves. That's cute, but in the lab, and you've done this in the lab yourself, you made mixtures of things when you did the reaction. So unless you're willing to go through the trouble of doing chromatography to separate everything out, then isolating it and doing NMR or IR or mass spec on each of those individual things that came off the chromatography column, you know, you're going to have a lot of trouble identifying what it is by itself. That said, you having a starting molecule and being able to guess as to what the chemical shifts probably are, what the splitting patterns are, that's useful because that can really help you quickly say, well, this spectrum is or isn't consistent with what I think the product is. And in reality, there are a lot of really good computer fitting algorithms that if you have a pretty good guess as to what's in the reactor, then it can actually use known spectra of those molecules. And if you end up with a mixture, it can deconvolute which peaks are due to which molecule in the mixture. And I know that's a really long answer to your question, but yeah, it's I don't like teaching chemical shifts as absolutes because they're not. Like there's a huge range, especially for protein and carbon 13 MR in particular. There's a huge range over what those chemical shifts could actually be. I'm going through your final exam right now to see if there's any. Okay, that's a fair question. Yeah, it's the reality is when you go into industry, you'll be working with a database. If you go to any corporation or large government body, they're going to have a database that you're going to compare it to because why create all that work for yourself when someone else has already figured out what the spectrum looks like? Again, it's good to be able to take a molecule and say, well, this is what I would expect to see. So you're not blindly using the technique, but be realistic. Nobody like does this by hand, except for very simple molecules. Yeah, your final exam has a question on it within 1H NMR, and like it's very much one of those. Can you figure out which one makes sense in the context of the spectrum you're given? Do you still pick through it manually, even though? So generally, what happens is it would like you to give a guess. Now it'll search the entire database against your spectrum. The problem is that by not giving it a guess, it's just going to pick whatever matches all the signals, and you'll get varying degrees of reliability with that. But you also aren't like running a blind reaction. Like you know what you stuck into the reactor, so you know what's likely to be in there. And what you can do is you can specify, oh, probably has the following chemical formulas, probably has the following, structures, and it will search the database for those structures first, and anything that remains, then you can say, okay, find whatever these missing peaks would be. It's actually really simple software that does this. It's the same way a dating app works or any like matching algorithm works. It's basically it expresses your signal as a vector and then just does a dot product against all the other spectra and see which one gives the best match. So what you're really paying for with these databases is just a copy of the spectrum. But the algorithms that do it are super easy and super low weight on computers. And the software itself isn't even predicting what the spectra are. It's just saying like, well, here's the spectra for this compound. How well do the two overlap? Honestly, it was kind of disappointing when I realized how they worked. I was like, wow, I just expected something more complicated. It's like, nope, keep it simple. Yeah, batching algorithms are super easy. If you know how to program in C++, you can set one up yourself. Again, all you're paying for the database is the spectra. But if you're looking for it, spectra1.spectra2. And it does it for all spectra. So like it's really, that's all it's doing is multiplying two vectors together. Like if you had the spectra saved into a file, it would probably take me about 20 minutes to write the script that would do it. Because what you may have noticed on all the NMR spectra is they don't report intensity. There's a reason they don't report intensity. They'll report normalized integrated area, but they never report intensity. When it comes to next semester, we're going to still have characterization. You see it a lot more in Orgo 1. Orgo 2, you see it less for two practical reasons. One, it's less the emphasis. Two, it's harder to find software that will predict those types of NMR spectra. So particularly things like alcohols, amines, and carboxylic acids. NMR database doesn't do it. Most software won't do it. Thiols are another one. They won't do sulfur. So most freeware NMR software only does carbon and hydrogen. Won't do anything else. So practically, it's hard to come up with example problems of it because people don't publish the spectra or they're behind paywalls, and you can't generate them yourself. IR gets more boring at the higher levels. There are nuances with aromatics. You can get ring breathing, and there are specific modes. And yes, you in principle can tweeze out like different positions on the benzene ring based on bending modes. But the reality is, beneath 1,000 wave numbers, we just use the fingerprint region in a database. Things like esters, ethers, most of the carbonyl chemistry we'll be doing, ketones, aldehydes, they look really similar under the IR. It's very hard to tweeze them out because there's little nuances in the vibrational modes. So the IR becomes less useful in that regard. And again, we would just stick to the fingerprint regions, 1,000 wave numbers and less, because that's going to give us a more definitive answer than trying to like tweeze out the functional groups. So they're still used. I mean, I don't want to make it sound like you don't need to remember the information, but we're kind of seeing the limitations of you being able to say, okay, based on the spectrum alone, I know I have this. You can tweeze out a functional group here or there, but the hard reality is that unless there is some real signature to your compound, it's going to look like all the other compounds with that exact same functional group. The better test we're going to work with in Orgo 2 are the actual qualitative test. I think that's lab 4 or 5, where you're going to go build up a flow diagram to say, okay, I'm going to test aldehydes, ketones, alcohols against a barrage of compounds and see how they react. And based on how they react, I can use that as a qualitative test, and that's going to be far more definitive than sticking in an IR because, again, a ketone and an aldehyde are going to look really similar in an IR. Big thing is you can't oxidize a ketone. You can't take it from carbon double bound to oxygen to carbon with 3 oxygen bonds. You can do that with an aldehyde. So if you put a drop of chromic acid in there and it turns green, you know you have an aldehyde. If you put a drop of chromic acid in there and it doesn't turn green, you know you have a ketone. And if you know you're working with alcohols, you can figure out if it's primary, secondary, or tertiary because tertiary alcohols can't be oxidized. So if you put a drop of chromic acid in there and it doesn't turn green, you know you've got a tertiary alcohol. Whereas primary and secondary alcohols react with chromic acid to turn green. We're going to, now that we fixed the lab manual, is going to be a lot better. You're gonna do preparation diphenylacetylene, which you've already done, so that should be an easy lab. And then you're actually going to do nitrate of benzene ring. Yeah, the final is only 22% of the grade, so if you've got an A right now, you've passed the course. During regular semesters, what I generally pass out is a slip of paper estimating what it takes for you to get, like, with the highest possible grade you can get, what the next grade down is. And I have students like to get an A, you need a 60, and to get a B, you need a 10 on the finals. Like that means you have a C. Like you can't do any worse than that one letter grade, than that lowest letter grade. For some people, that's really exciting, especially if they've already been guaranteed a transfer. It's like I just need to like show up and take the final, and I pass the course. For some people, it's terrifying because they need like a 95 to pass the course. let's see what the enrollment is looking like for the spring. Two seats left in the Friday section for Orgo 2, and the other two sections are waitlisted 5 students deep. Let's see how the other sections are doing. Not doing bad. Let's see how Jin Kim's doing. I used to be the chemistry lead, so I'm always curious about how the enrollments are doing. How weird. How's it going? At least one of you's out of tune. I recently restrung my fiddle and got to remember how obnoxious it is when you restring an instrument. It takes about 3 passes to get the strings right. Guitar, it's a little bit easier, I think, because you can get the 2 outer E strings, and then they start tightening up as you get along. But definitely with a fiddle, you tighten one, watch the neck go, tighten the other one, and since there's 4 strings, each one really starts playing with the tension on the neck. Are you restringing with steel or brass? Fair enough. These were silver when I bought them. I'm sure if I hit them with a little bit of Brasso, they might actually look silver again. My personal favorite is silk over silver, or silver over silk. But I also prefer kind of that folksy bluegrass sound. Oh, they will cut you to bits, but once you get the calluses, they're really nice. Yeah, it's weird to play on brass now. I think my old one, I can grab it. I think that one still has brass strings on it. Yep. Don't understand how you righties play like this. So these are much easier to play on. Probably have to focus on the right string. Right, it's all upside down now. Yeah, this was always an awful guitar to restring because the pegs in the bottom weren't very good. Ended up having to replace them a few years into owning the guitar. All right, that is the last live stream of the semester. Again, if you got questions for me, shoot me an email. I'm going to prefer to work by email this week, but if you absolutely positively need to talk to me, just send me an email and we'll see if we can work out a time. I will see several of you next semester for Orgo 2.